In a previous lesson, we learned the difference between a perfect square and an imperfect square. Perfect squares are squares with rational side lengths. We can easily think of a math fact that answers the question, what number times itself is the area of a square? Another way of saying that is, we can easily find the square root. Imperfect square side lengths must be found by other methods. In our last lesson, we saw that a number line is a helpful way to estimate square roots. Let's review this by trying to find the square root of 23. Since 23 is between 16 and 25 on the number line, the square root of 23 must be between the square root of 16, which is 4, and the square root of 25, which is 5. Since 23 is much closer to 25 than it is 16, we know that the square root must be more than 4.5. And so an estimate for the square root of 23 would be approximately 4.8. A closer estimate can always be found by using a calculator. Now let's look at what happens when there is a negative sign with the radical. Remember that the negative sign reads as the opposite of. In the example of the opposite of the square root of 8, we can begin by estimating the square root of 8 as a number in between the square root of 4, which is 2, and the square root of 9, which is 3. But once again, in this case, it is much closer to the higher number, which is 9, on the number line. Now thinking of opposite, we can think opposite of approximately the square root of 8, which is negative 2.8. Then all we need to do is simply graph it on the opposite side. You should be aware of a special case. Notice that in this example, the negative sign is inside the radical. So we now ask ourselves the question, what number times itself is negative 25? 5 times 5 is 25. Negative 5 times itself, negative 5 times negative 5, is also 25. There is no number times itself that is equal to negative 25. That means that there is no real root.